Hello, today we're going to teach you how to do the 2014 AP Calculus BC FRQ number 1. So first off, when we read this problem, we instantly see, for one, it is graphing calculator active. And this is going to come in handy. We already see a formula up here, so we might want to go ahead and just plug this into our calculator right off the bat, because if they give us a formula like this, then we are going to have to use it. So to make things simple, I would plug this into your calculator. Now, let's actually read the problem itself. We see, grass clippings are placed in a bin where they decompose. Most of this is garbage. We do not really need to know this except the fact that they decompose, which might come in handy because this indicates that something might be negative along the lines. Decompose. And it also gives us an interval from 0 to 30, which is going to be very important as well. Next, it gives us the amount of grass clippings remaining in the bin is modeled by this equation. Okay, so we should probably note this equation is the amount of grass clippings. And then lastly, it gives us units of measure. A of t is measured in pounds, and then t is measured in days. Okay. So now that we've completely identified and broken down each parts of this problem, we should actually look at the questions they're asking us to solve. So for A, it asks us to find the average rate of change. Okay, which you should instantly be thinking when you see average rate of change. You should have alarms going off in your head to say, average rate of change? That means you want to do the equation of a secant line. And that equation is your old f of b minus f of a all over b minus a. And then it gives us of a of t, so obviously our equation given. And then finally it gives us our interval that we're going to be plugging into our formula. Now something else to note, indicate units of measure. This is interesting. Even if you didn't know how to do any of this other stuff in A, it says indicate units of measure, which is a point all on its own. So at the very least, you can get this because they are going to give you a point for units of measure. So if you give some answer, but you give the correct units of measure, you will get a point. Right. So we want to plug in 30, as this is our B, and then 0 as this is our A. And because, as we mentioned, this is graphing calculator active, you might want to circumvent the time required to actually writing this problem out and doing this all in your calculator. So I'll give you a second to type this out, and let's see if we get the same answer. So the answer we got is negative 0.197 pounds of grass clippings per day. Did you get the same answer? I sure hope so. Now let's move on to B.
Alright, so reading through part B, we see it asks for the value of a prime of 15, which is the derivative of the function they gave us. And it says, using correct units, interpret the meaning of the value in the context of the problem. So you're going to actually have to explain what this means. So the a prime of 15 part is the easy part. You just use the function that you already stored in your calculator, and you find the derivative at t equals 15. So what we get for that is a prime of 15 equals negative 0.164. Okay, so now we have to explain what it means. And this is basically just the amount of grass clippings in the bin. It's decreasing at a rate of 0.164 pounds per day at 15 days, at time equals 15. So you can write that down, and the important part is you just have to have the time it's at which it's happening, and you have to have the units, and you have to explain that it's a rate. But you can do it in your own words. Alright, so now we move on to part C. So it says, find the time t for which the amount of grass clippings in the bin is equal to the average amount of grass clippings in the bin over the interval 0 to 30. So it says, find t for which a of t equals the average amount of grass clippings, so average amount of A of t from 0 to 30. So if you remember, that's just 1 over b minus a, which is
30 minus
30.
0.
Yeah, 1 over 30, times the integral of 30 to 0 of a of t dt. So now what you do is you just put it in your calculator like this. You put this function and you graph it, and then you put in this and y and you graph it, and then you find the intersection, and that will show you at what value of t the amount of grass clippings equals the average amount of grass clippings over the interval. And what you end up getting is t equals 12.415 days. Okay, now we can do D. So now we move on to part D. So it says for t greater than 30, L of t, the linear approximation to A at t equals 30, is a better model for the amount of grass clippings remaining in the bin. Use L of t to predict the time at which there will be 0.5 pounds of grass clippings remaining in the bin. Show the work that leads to your answer. So what it's asking basically is, so what it's saying is L of t, use L of t past t equals 30, and it says linear approximation, so we're going to assume that they mean a tangent line approximation. But they don't actually give us L of t, so we're going to have to find it. So L of t equals A prime of 30, because they said at t equals 30, times t minus 30 plus a of 30. So that's our tangent line. But what it's asking for is to find t where L of t equals 0.5. So, of course, we're going to be using our calculator for this. And so we're going to do basically the same method that we did in here. We're going to graph 0.5, y equals 0.5, and we're going to graph L of t, and we're going to find the intersection. And it'll tell us that at t equals 35.054, there are 0.5 pounds of grass clippings remaining in the bin. So that's everything we need. So now we're done with number 1. We can move on.